All right, thank you all. We're going to get started now, so if we can take our seats and let's give a big round of applause for Matt Scharr, and we are going to get a very cool presentation.
Thank you. Super cool to be here. I'm really happy to see a bunch of elementals and a good crew for the PDX Video Tech Meetup. Okay, so let's get started. Like you said, I'm Matt Scharr. I'm a senior software development manager at AWS Media Taylor. And we're going to talk about ad prefetching today. So this talk is called Prefetch or Perish, Live DAI at Scale. So we'll start with a brief introduction, and I'll describe sort of where live ad insertion is today, and we'll talk about some of the problems and challenges and what we can do to hopefully help publishers achieve better monetization results without compromising the streaming experience. So dynamic ad insertion today, there's a super high demand for DAI. Live audiences are shifting more and more to digital platforms from traditional broadcasters. This is driving a lot more traffic over some traditional infrastructure that does not deal with high concurrency very well. A lot of the digital platforms for video are based on video on demand, not on live streaming. A lot of the ad insertion work is really meant to be sort of naturally spread out over time as different people join streams or different users join streams. And it doesn't deal well with super high concurrency where all of a sudden there is an ad break and everyone watches ads all at once. For traditional burnt-in ads, this is okay because we can measure ad insertion in different ways. But when you have personalized ads and you're serving unique ads to every viewer with their own attribution for each viewer, all of this infrastructure really struggles with doing that at scale all at once. This can be problematic because there can be impacts on the viewer experience and also revenue. So if the DAI infrastructure goes down or is overstressed, adds latency, you might end up buffering the stream. All of this decisioning happens sort of at the live edge, and when we take too long to reach a decision for an ad, that could compromise the streaming experience by preventing the client from getting a manifest, which then prevents them from getting the latest segments. It erodes their buffer, and then the client might pause. Moreover, if the ad systems themselves go down, you might end up timing out on the ad decision and not inserting any ads at all, and that has revenue impacts for the publishers that are trying to monetize their content. So, as you might have guessed, these are kind of tricky problems to solve. We can't necessarily, or we don't necessarily have control over some of these back-end systems. There's a lot of layers upon layers upon layers of decisioning that happens in dynamic ad insertion, and we may not be able to control for those. So figuring out what to do, we need to think about what we can control and how we respond. So why is it hard? Your concurrent viewers can reach tens of millions of clients all connected at the same time. This all happens in real time, like I described. It all happens all at once. So every one of those viewers is going to ask for an ad decision at the same time. Now there is some natural jitter. So with the streaming protocols that say my service supports, we're an HTTP-based protocol, and we have HLS and Dash support. There's some other formats that are gaining traction that also provide DAI experiences, but we're just going to talk about sort of HLS and Dash manifest-based streaming with segmented video. So really, the only amount of jitter you're going to get is like a segment's worth of jitter. Partner services that I described before, these are your demand-side partners, other ads proxies. They don't often know when load is going to occur. There's actually an industry working group that is trying to solve this problem right now by piping real-time metrics to these partners so that they can scale with some amount of notice rather than just getting a thundering herd of requests for ad decisions all at once. And then the other way we can solve for this potentially is like adding extra latency. So you could delay the stream, right? Like we could potentially say, all right, just give me a really big buffer. And that way, if I have trouble fetching the manifest or fetching these add decisions, I'll erode some of that buffer, but it'll be okay because the playhead is way far behind. That's not a great experience for viewers, and especially if you're streaming live sports content, you might end up in a situation, this is the classic example that everyone gives, where your neighbor or the bar next door sees the goal scored before you, and then you are sad. Or worse, your friend texts you about it 30 seconds before it happens. This has happened to a few folks I've talked to, and it's not a great experience. You want to feel like you're in the moment with everyone else. And so we as providers, as vendors, as publishers, we don't want to add a lot of extra latency to these streams. It's just not the right solution. So we're going to talk about prefetching. It turns out it's also hard. Prefetching, I'll explain this concept in a second, but it essentially has to do with predicting the future. So our job is to figure out what ads are going to be inserted later. We allow publishers to retrieve ad decisions before they're needed. And what this means is that you can set up the right ad tag, which is to say the parameters that go into deciding what ad to show someone. We want to call that tag, or we want to send those parameters to the decisioning engine at some point before the ad break appears in the stream. That way, when there is finally an ad insertion opportunity, we won't have to wait, and we won't potentially overwhelm our dependencies because we were smart about when we made requests. The resulting VAST response is then stored by whatever system is doing this prefetching. VAST is a protocol that we use you can just think of it as like a manifest for ads, so to speak. And it contains all of the metadata that describes an ad, along with tracking information and other stuff that might be useful for a client who is playing it back. Doing this is going to improve insertion rates and allow for anything new, like a new ad that hasn't been seen before, to be recognized and then conditioned if it needs to be changed in some way before it can be inserted into the stream. Media Tailor is like what we call a stitcher, a server-side ad insertion platform, and what we try to do anyway, and there's other platforms that do similar things, but what we try to do is ensure that the ads that are inserted match the quality of the video stream that they're going to be inserted into. And so that conditioning takes non-zero amount of time. We use Media Convert for that. It's usually very fast, but we're talking, tens of seconds potentially for the turnaround time for that. So if you're expecting a lot of new creatives, a lot of new ads that are going to be inserted, you want to try to do that as early as possible, or figure out how far in advance you can make that decision, so that if there needs to be any conditioning done to those ads, you've got the time to do it. So take my money, this sounds great. However, I'm not sure if we really answered how this solves for scale. It's great that you do this earlier, but you might end up just, DDoSing the ad infrastructure sooner. I don't know if that really works out. You also might not know what to ask for. If you haven't seen the break, the metadata that you typically would supply to the ad decision server might not be known to you at that time. So to think about how we're gonna solve for that. And even more tricky, there might be regulations or laws that constrain what you can and cannot show to a particular viewer at a particular time of day or to a particular audience. And that complicates this idea of predicting the future of who's going to be watching in the future, and what time are these ads actually going to be consumed. So let's talk about scale. We can traffic shape, and that's going to help us. And we'll get to why it's not enough in a second, but essentially the idea is, and I alluded to this earlier, we want to distribute requests over time. So we want to lower these peaks experienced by our partners and ensure that as viewers start streaming, we immediately get ad decisions for potential breaks that might occur. We also want to limit the amount of work done on behalf of individual viewers at that time, because if you have a lot of people joining a stream all at once, you might end up in the same problem where, oh my goodness, the rate of new sessions joining is really high, and I have to decide all of these things as all of these sessions are starting. So you could foil your attempts to spread out that load. So what we typically see in like just-in-time ad decisioning is this really big spike of requests, and that happens over more or less a segment duration. So if you have 4-second segments, new video arrives at the client or from the origin every 4 seconds. And you'll see distributed over time, this big spike of requests. And as each client is requesting a playlist or a manifest, Media Tailor or another stitcher will, do that decisioning in real time. This is an example from some event that we supported where there was, a rate of like 7 million or close to 8 million requests per second, and that's just a lot. What we really want to see is a pattern like this, where we take the same volume of traffic and we spread it out over like a minute, like many, many seconds, so that we depress that peak. And then as requests come in, we can serve those requests and spread out the traffic we send to our decisioning dependencies. So yeah, it sounds great in practice, but I would also be skeptical, like our friend Fry. How do you apply this to the real world? There's all sorts of other considerations that we need to take into account when we're dealing with a real use case. So we're going to talk about KO Sports. They are a customer who've used Media Tailor in the past for their streaming for ad insertion. They're one of the largest sports broadcasters in Australia. They are part of the Foxtel group, which is now DAZN. They're built on AWS, and they've been streaming 400 or so professional and amateur live events each week. At any given time, they're streaming between 20 and 50 simultaneous events at the same time. So that can be Australian football, it might be rugby, cricket, netball, soccer, all of these things, Formula One. The problem that they have is that they have this classic issue where during these large-scale events, all of the just-in-time ad decisioning would overwhelm their partners, their ad server partners, in doing the decisioning that needs to happen for each one of these breaks. It essentially resulted in lost ad revenue. Breaks were constantly underfilled. They also have some rules in place for their traffic that prevents like partial break decisions from being inserted, because there are burnt-in ads in the underlying content, or there could be burnt-in ads. I'm not sure if that's the case for every single event, but you end up with this really gross experience where, let's say you make a request for an ad break, say the ad break is 2 minutes long, and you only get 30 seconds of ads back, or 45 seconds of ads back. And typically Media Tailor would just say, okay, well, too bad. We only got 40 seconds of ads back, and we'll insert that content, and then we'll crash back to the original stream, or we'll insert Slate for, however much longer, a minute, 2 minutes, whatever the remainder time is. That can be a really bad viewing experience. Either you're staring at Slate for a really long time, or you crash into the middle of someone else's ad, which is problematic for a bunch of reasons. There could be competitive exclusion considerations, and it's just a bad viewing experience. I'm sure folks in this room have had that experience where you watch an ad and then all of a sudden it gets cut off by another ad, or an ad ends and then it gets, you get shoved into the middle of whatever underlying ad was there. It's just a terrible experience, and we want to avoid that. And what that means is that we actually are configured, or they configure our service to drop the entire decision, drop all of the personalized ads if it doesn't meet a minimum threshold. So if it's not within like 10 seconds or 30 seconds of filling the whole opportunity, we just drop the whole thing. And that's quite a lot of money left on the table. They took a goal of boosting their ad fill rate to above 70% via ad prefetching, and we helped figure out a solution for their problem. One of the key challenges that we had was that ad breaks can change. They shift around in time. And There are certain rules or laws that govern when that content or when and what kind of ads can be shown for particular break opportunities. For example, gambling ads can be quite lucrative for the publisher, but they're not allowed to be shown during specific hours of the day. And so if you're doing prefetching, like let's say, earlier in the day, and then the break opportunity isn't until later in the day, you might be missing out on revenue. Or vice versa, if you do prefetching, outside of the window where gambling ads are not allowed, you might end up inserting a gambling ad when that time window changes, and all of a sudden gambling ads are not allowed anymore. And they have, I think the regulators in Australia have like a 3 strikes and you're out policy, which is, you just can't make mistakes on these kinds of things. The penalties are quite severe. So if an ad break shifts in time, we have to figure out a way to potentially invalidate the ads that were prefetched if they're not appropriate for the break opportunity that comes up. The other challenge is that ad breaks, maybe they don't shift around in time, but they can change in length. So how do you know that the decision you've made is appropriate for the length of break that you have? You might have only fetched like 30 seconds of ads for a 3-minute break, and then we're back to the same problem that I described earlier of having to throw out the ads because in practice you don't want to show someone 2.5 minutes of slate or crash into someone else's ad. So the way that we solved for this was by allowing operators to define specific conditions under which the ads can actually be consumed for a break opportunity. That includes effectively meta from the SCUDdy35 signal, metadata from the SCUDdy35 signal that's in the stream. So that typically describes a break. You'll get duration. You might get some contextual metadata about the stream itself. You might see the type of content it is or the genre of the content. And all of that can go into helping ad decisioning servers decide what break or what ads to show for what break. And we can use the same criteria to decide if the prefetched decisions actually match the break that we're targeting. So the outcome, we worked very closely with the KO Sports team to figure out bottlenecks for their workflow and identify and build an effective prefetching strategy for them. In addition to building a prefetching solution, we also worked closely with them to optimize timeout settings across the delivery stack and just ensure that the innermost timeouts were always less than the client's timeout. Bad things happen typically when you have lots of stacked clients and servers, and the servers are waiting too long to return a response, and then the client times out on the server, and then the server gets locked up because the client then sends a request to get another, a retry to get another decision, and it can actually overwhelm those servers pretty fast. And we've seen this throughout the ad tech stack over and over. So it's been really important for this customer and for other customers and for us ourselves to ensure that these timeout settings are optimized so we have a really clean delivery chain of one server delivering to a client or sending back an error, and then and then so on and so on and so on. They also increased the number of ad decision server line items and introduced their own like 6-second house creatives to help round out decisions. That way they still return something even when their partner services might turn out. And the other thing that the 6-second creatives helped with was the fact that ads aren't always like 15 seconds, 30 seconds, 60 seconds long. In practice, you might get an ad that's like 13 seconds long, or 29 seconds long, or 62 seconds long. And when you're trying to fill breaks that are exactly 2 minutes or exactly 3 minutes, it helps to have filler content essentially that can help bridge the imperfect durations that you're trying to all string together. And to date, we're very happy to report that their ad fill rate has increased to more than 95%. And a lot of that is due to not only the prefetching mechanism that they built, but these other optimizations that they delivered as well to ensure that all of these dependencies work in concert well together. So let's talk about some next steps and stuff that we learned. In some recent improvements, we've launched the ability to simplify prefetch scheduling. We used to require customers know exactly what window of time they wanted the prefetching to occur. Now we can support recurring prefetching, which lives essentially, over a certain period of time, but will sort of re-up ad decisions as the event continues or as the stream continues. So when you start, you fetch some ads, and then as break decisions are reached, you fetch more ads. We also implemented an improved traffic shaping algorithm to help lower the peaks to ADSs and other dependencies. We've allowed operators to configure expiration times for ads that have been retrieved. This helps with some of the problems I described earlier, where you might not be allowed to show an ad after a certain amount of time. Also, the reporting pixels, so the callbacks that customers use to say that an ad was watched by a given viewer, those URLs might actually expire. And so we need a way to throw them out and fetch new content if that happens. And then finally, we expanded supporting matching criteria to include additional SCUDdy35 metadata, like the segmentation type ID, for example. So you can target specific kinds of breaks or specific kind of segmentation types for retrieval and insertion. This is a cool diagram that sort of describes at least an example of a cricket match that uses recurring ad prefetching. These little pink boxes are ad breaks. We then have a delay period after the ad break. This is to ensure that when you've inserted a bunch of ads, that there's enough time for all clients to report that all of these ads have been viewed. That helps ad servers plan for the next break. There's this concept called frequency capping. We don't want to serve the same ad to the same viewer too many times. It's a bad experience, and also you might oversell an ad. This little green spot is the retrieval window. So we spread out requests to the ad server over that period of time, and then the gray window is the time during which we are allowed to consume those ads before the next ad break occurs. And then that just wash, rinse, repeats over and over and over again throughout the game. This is what it looks like from like ads inserted versus ads retrieved. We have the ads retrieved line is this orange line here, and the inserted ad is the blue line, and they sort of stagger against one another. So as we retrieve ads, and we consume them, then we retrieve more, et cetera, and it just goes over the entire length of the broadcast, as opposed to like a single spike when we just retrieve and insert a bunch of ads all at once. So some lesson learned, just to restate some of the things that we've gone over. Ad insertion for high concurrency live events is particularly hard because it just sends tons of requests and tons of work to all of these backend systems all at once. Without prefetching, it requires a lot of scaling ahead of time. It becomes very expensive. And even prefetching as a solution requires some pretty careful planning to execute well. That said, we have had customers implement prefetching in like a weekend. There was a broadcaster that I think they were doing, I can't remember if it was soccer or if it was cricket, and they were able to stand it up in like 2 days. Super impressive tech team. Timeout settings across the delivery and ad tech stack have to be optimized well. That means your CDNs, your SSAI platforms, ad decision servers, any partner or proxy servers, all need to make sure that they're well aligned so that you don't end up with overwhelmed servers or clients that are retrying after the server times out. Like I mentioned, ad creatives aren't always exactly 15 seconds or 30 seconds or 10 seconds. If you include a mix of short form and house ads of varying durations, that can help fill in gaps, and you might save yourself from having to drop a whole break because you didn't quite fit the allotted time. And then not all breaks can be filled with the same ads. We want to make sure that we're using appropriate matching criteria and expiration timelines so that you don't run afoul of any regulations or hurt the viewer experience in some way. I want to say a particularly heartfelt thank you to the KO Sports team. They have been fantastic partners in this. This is Rupesh and Niklas. Really good partners, really sharp technical team, and they helped us design the initial Prefetch feature. We worked very closely with them to figure out exactly how to solve for their somewhat complex use case. So we're really happy that we had the opportunity to partner with them on that. And that's it. Are there any questions?
Yes.
Okay.
Let's start. Sorry, let's start with with the hard question. Like, does SSAI versus SGAI makes a difference? Like, do you have more time with SGAI to make a decision, and then do you need less prefetch? What is the threshold here?
Yeah, so there's not necessarily a difference between ad decisioning for SGAI and SSAI. So I'm hoping that everyone is familiar with server-guided ad insertion versus server-side ad insertion. Server-guided ad insertion, I'll just give a brief explanation, is essentially where the client is responsible for stitching the stream together. It's kind of a hybrid between server-side and client-side ad insertion, where there's two, main competing standards for this. There's HLS interstitials and dash alternate MPD, or alternate event timeline. I'm forgetting exactly the title. Yes, yeah, there's a bunch of different versions of it, but essentially it's the same thing, where the client gets, instead of getting a personalized manifest, which can be really expensive for delivery stacks and CDNs and stuff, if you're just generating like one individualized stream for every single viewer, that's not super efficient. Most clients are receiving the same content most of the time, and it's just the ad break interstitials that are different. And so it would be better if the clients could fetch the same video stream, have efficient caching for that, and then when ad breaks occur, the client can go ask for the ad content and then fetch that. But we don't want the client interacting with ad servers directly, or all of these, having to resolve a bunch of vast wrapper redirects. It's just a lot of work on the client, and we've had customers complain to us that say, we really want to abstract as much logic away from the client as possible. We don't want them having to resolve like ad breaks and figure out how to piece together different media files into a coherent stream. We would really like that to be presented to us as already decided. And SGAI tries to solve for that by allowing the clients to receive a heavily cached primary video presentation, and then the unique ads that are delivered to them is served through what in HLS is called an asset list, and I guess in Dash is like an alternate MPD. To your question, Nicola, there's not really a timing difference, at least in a naive SGAI implementation. So the clients are all still going to ask for the interstitial at roughly the same time. There'll be some amount of jitter. But if you don't figure out how to preempt that decision somehow, or move it up, or jitter it farther than just that moment in time when the ad break appears, you're going to have the same problem that you do. The ad server backends will crash because they're not scaled up. And in fact, it becomes a little harder with SGAI because some of the systems are not going to be receiving like heartbeats in the form of like manifest requests from every client, because now all of the manifests are very efficiently cached by the CDNs. So Pantos has developed a solution to this with some coordination with the industry and some recommendations from actually one of our PMs to try and like allow customers to tell clients that there might be an ad insertion opportunity coming up. They basically overload the preload hints tag for HLS, and that allows you to tell the client that, hey, there's a resource that the server has that you should fetch before it's needed. And we can piggyback on that mechanism to effectively kick off the prefetch process early, or kick off the prefetch process as prefetch and not as part of the just-in-time decision. So that's the mechanism that you would use for accomplishing prefetch or pre-decisioning for something like HLS interstitials. I'm not sure if Dash has an equivalent of the preload hint that can be used for that. I need to speak with a few people and see if that's coming. So.
No, that's fascinating. So is early ad break notification part of the pre-hinting, or is it totally a separate subject?
Early ad break
EABN.
notification, as in, are you talking about the IAB group that's trying to figure out how to like identify ad breaks or identify scale? So that
Yeah. It's well, I'll roll into the questions to
Sure.
that. We'll talk about that later. Obviously, this is my entire life that I deal with at my job. With the UFC coming up, as the Super Bowl, as AFC championships in our company, hurting, and the whole, everyone joins at X time, whether it's halftime show, whether it's, this is feeding back, whether it's halftime show or whether it's the main bout of a boxing fight or whatever it is. We've been researching and innovating in interstitials 3 years ago, whatever, right? They're not supported across devices. Fundamentally, device fragmentation is a limitation in all of this.
Yep.
But pod serving from DAI, a Google product, and I know Media Tailor is different than DAI from Google, but we're talking about the same technology.
Oh yeah, it's the same problem.
Same
that they're
thing.
solving for. Yeah.
So obviously, when it comes to large scale events, you can't just we can easily take over the entire stack, right? And we'll make it fall. We won't monetize. It's a big failure.
Yeah.
How does what you're talking about with prefetching? I see the herding spread out. I see and that's over 1 minute or so, not over 10, 20.
You could, so Media Tailor allows you to spread it out over whatever time period you want. And depending on your audience size, you may need to do that.
Okay.
Some of the stuff that we're working on now is allowing customers to just give us a peak like TPS and say, whatever you do, don't exceed this RPS to my dependency. And that means we may need to spread out those requests over a longer period of time. Now there's a trade-off there. If the time window is dynamic, it means you might miss the next ad break opportunity. And then you might end up in a situation where you have to send a bunch of just-in-time requests to the ad server. We also recently developed a feature that allows customers to just shut that off. So if you are relying on prefetching, you can say only prefetch. Don't do just-in-time decisioning. And that way, if you are trying to maintain a really low or really consistent request rate to the ad server or all of those dependencies, you can just say only make those prefetch calls and don't do any just-in-time decisioning. Now, there is a trade-off there because you may lose revenue from that, and it might be better if the ad servers could simply like load shed, and so we could try to fill those breaks if possible. That would be ideal.
Or even offer in other break opportunities for when you first join a live stream at that section of like, okay, we're overcapacitated. We are going to not fill
Correct.
X, Y, and Z, but we're going to have 2 more opportunities that we're not going to fill in the people that got filled the first time, right?
Yeah, you can fetch multiple break opportunities at a time. You could essentially like amortize the work over a long period of time and fetch multiple decisions so that if you do end up in that situation, then you're able to recover a little bit, or potentially all of it if you have those fallbacks or backups.
And when we talk about recovery, we're talking about monetary recovery.
Yes, sorry.
Yeah, and that's
all
fine.
of this
That's
is about money right now.
Of course. This is what pays our paycheck.
Yeah.
But monetary recovery, obviously good experience for the viewers, number one, but monetary driven. So
yeah, the idea is really to make sure that none of what we're talking about interferes with the smooth streaming experience for
That's
viewers.
right.
All of this is happening asynchronously and outside of manifest delivery or video stream delivery.
all right, 2 more aspects. I'll make it quick for other folks. So staleness, ad staleness, fill rate, all that stuff's very important.
Yep.
How do you deal? You mentioned something like I fulfilled a gambling ad, but it's now 3 o'clock. I fulfilled it early. Right. Is that how are you fully going after? You're invalidating the ads?
So we invalidate the ads. So that there are a couple ways that you can do it. One, you could set so because you can time when these things happen, you can set an expiration and you say, okay, I want my ad to expire after so long. I've done this retrieval at this point, and I don't want the response to be valid or to be used for any ad insertion opportunity after X point in time. The other thing you can do is identify an ad as eligible for certain kinds of decisions through Scuddy metadata or some other stream metadata that your stitcher knows about in some way. It doesn't technically have to be carried in the Scuddy 35 message payload. You could potentially glean it from something else, depending on what your encoder or what your packager is able to surface. So as long as you have some hint about what that break opportunity is, then you can use that to figure out, okay, these ads have been tagged with this other piece of metadata that matches what I see in my stream, and if not, you just throw it away or you hold on to it for another opportunity that might match. A good use case for this is, say, you might want to fetch like overlay ad opportunities. Let's say you want to do like an L band or something like that and not interrupt the stream. You can signal that in the stream, signal an overlay opportunity. But you may have already prefetched like linear ad breaks, and you don't want to use those. You don't want to match those with the overlay opportunity because that would, paper over the stream in a way that you don't want.
Yeah. No, that's fantastic. Squeeze backs, overlay opportunities are very interesting.
Yeah.
Final question: what about multi-view? Okay, so let's start going in. This is a very popular subject lately. We just released multi-view for UEFA because they all start at the same time.
Yep.
And because they all start at the same time, there's a variance of maybe 3 to 4 minutes of overage time per game, and you all enter the ad break sections at the same time. So multi-view has 4 screens up, and you have competing ads now, and a problem.
Yes.
The whole thing comes up, a whole new world that I've never experienced as far as problems. Do you have any thoughts about multi-view, about this? Obviously, when you do it on the client side with 4 streams, 4 players, X, Y, and Z, totally different problem when you composite on the server side and you control that. So that's my final question. Any thoughts on multi-view?
Yeah, this is a hotly debated topic and a really interesting one for ad insertion. There's all sorts of problems that you might have to solve for, say, competitive exclusions. If you have 4 streams that are active, typically the use case that we see is like multi-view within a program or within a specific program. So you think about like the F1 example, right, where you have like different multi-camera view. That is probably fairly compatible with dynamic ad insertion because it's the same logical program, and they're not going to like have different ad opportunities competing for attention for the viewer. The way you might solve this if you had different channels, like let's say you give your viewer the option of watching 4 distinct channels all at once that might go to ad break at different times, or maybe they go to ad break all at once. Presumably they're not going to be listening to all of those at the same time, and you could potentially infer which to care about for the purpose of ad insertion by which square or which view was active. And that would probably be a good experience, and you could probably negotiate with advertisers. You would have to negotiate that product and that ad opportunity, and I'm frankly not sure how that's described at the ad server. But I think that if I were an advertiser, I would want to know and indicate whether my ad was allowed to be shown in a multi-view context. And so I think that would affect CPMs. You might not get quite as high a price for those ads. But again, that's all negotiable, and a lot of this stuff is bid up in real time. So depending on the value of the content, you might still see high CPMs, but a lot of this is just dependent on who's the ad, who's the viewer opportunity, what is the technology that's actually being used. But really fascinating topic right now.
It really is,
Yeah.
and it's new to me. Like, you cannot have Pepsi and Coke on the same screen. You can have Lowe's and Home Depot on the same screen. And CPM auto, muted versus unmuted play, cost per ad. It's a fascinating subject.
Sure.
So, enough from my side. More questions over here. Let me hand it off.
So, continuing on that kind of train of thought with the Pepsi and the Coke not being on the screen at the same time, I come from a kids' entertainment background
Yeah.
where in broadcast there's very strict rules. how companies interpret that into the digital space is interesting these days, right?
Absolutely.
Have you guys thought about more of also a repel model, right? Where you literally tag an ad saying it can't air in any content that is also tagged to contain this, this, and this?
So that logic would probably live in the decisioning engine.
Okay.
And we would be able to provide that contextual metadata. There's a lot of work being done by publishers to try and provide ad decisioning platforms with as much information about the ad opportunity as possible. And you can use MediaTailor and other like elemental products, and there's other encoders that allow you to pass that metadata, through that sort of ad decisioning pipeline, so that the decisioning engine can make that right call of whether an ad is allowed to be shown or not. And I believe that you can define allow or exclude lists for certain kinds of ads. Like you can exclude opportunities, like I only want to bid on this kind of content, or I specifically do not want my ad to appear next to, say, a car ad.
Right. Okay. And then you mentioned earlier that like breaks being defined in 15s, 30s, minutes, etc., kind of hard timing frames, but the reality that the content being delivered, right, is not. But are breaks in live events really that hard?
So a lot of times you'll see, like if there's a feed of the stadium, you'll see like the camera go into a really wide shot and it'll start zooming out over the field. Or this happens in Tour de France all the time, where they'll like start like filming like the countryside or something, and then there's some fuzziness in like the shot, such that the move to the ad is not really perceived as like a hard cut like you might have in video on demand content, where you have like a fixed opportunity size. It interrupts the broadcast, and then the broadcast resumes, or the video that you're watching resumes at the point that you left off. Right. For live streaming, that's not the case. And a lot of times you literally have someone in a like truck that's hitting a button that says go to ad. And typically it does contain like a duration. So when you say go to ad, you're going to indicate how long that ad opportunity is. But how that's couched in the stream, like how that's actually produced and aligned with the content, there's like human fudge factor essentially there in the camera feed that you're watching. And so even if you're watching something that's like super fast paced, the announcer will stop speaking, or they'll cut away from the last goal or the last action, and then there'll be some like filler time essentially that gives the producers time to say, okay, now it's time to go to ad. So the fidelity is it's close, but there's going to be some time, natural time, so that you as a viewer aren't immediately bombarded with the next piece of content. There's some transition, and I'm sure that's going to vary dramatically between sports, between different kinds of broadcasts and whatnot. Some customers will insert bumpers.
I was just going to say, so then you basically deliver to the ad engine content that's a second, 2 second, 3 second, 4 second of a bumper variety, so that you've got some kind of fill depending upon what might be needed.
And that can be orchestrated either as part of the ad decision, or it can be done outside of the ad server. So the ad server only sees like exactly the 30 seconds of ad opportunity that there might be. And MediaTailor does things like we will allow decisioning engines to fudge the duration of the break by some tolerance, like 1 second or 2 seconds. And we will actually drift out the content to accommodate that. So because we're dealing in segmented video, right, like if you insert 31 seconds of ads into 30 seconds of opportunity, you've just created more time in the stream. And you can push out the content when it comes back. Now, the effect of that is that you then have like a slightly more latency or slightly more delay. You've pushed your live edge out a little bit, but you could reclaim that time. the opposite is true too. Like if an ad server returns 29 seconds of ads, we could potentially, if we know of the segment that comes back, we can say, all right, pull that in by a second, and don't show that extra second of content that was overlapped.
Yeah. Cool.
And maybe one day we won't put gaps between content and the ads. Any other questions, folks? All right.
So you've talked about with the decisioning engines, the ability to, you may be asking for stuff now that will be shown 10 minutes later when it's not allowed to be. Do you have the ability in any cases to say I'm asking for something to go into this slot in the future? It's like,
To specifically identify the opportunity that's coming up.
or just a time, like I'm looking for ads after 3 p.m. or what, like do the decision engines let you specify when you plan to show
I see,
things?
I see. So I'm not entirely sure what the decisioning engine will allow you to do, but you can do that with Media Tailor. So we allow customers to specify different retrieval and consumption timeframes. So you can define a retrieval time frame that is, earlier in the stream, and then a consumption time frame that is later. So let's say you have a viewer that is watching, a football game, and you're prefetching the ad for halftime. You can say, I want you to retrieve this ad decision as soon as the viewer starts, within the first few minutes of the game. But I don't want you to consider that retrieval to be eligible for insertion until halftime. And so even if there are ad opportunities that show up before then, you might have specifically fetched that halftime break for that viewer, and then it's only allowed to be consumed when the appropriate marker happens in the stream. And that could simply be like any ad break after this point in time, or you could try to identify it by some marker characteristic of the break. Like there are literally break IDs that customers will send, and so you could map it one-to-one, but there's nothing that stops a customer from, say, declaring that a retrieval for prefetch could only be consumed, until sometime later. The caveat there is that there's no guarantee that that viewer is going to be around in like an hour or two, and so typically prefetch workflows operate, on like minutes timescales. So you're prefetching like a couple minutes before the break. Advertisers want to know that the inventory that they're bidding on is, worth bidding on, and the probability that someone is watching, 2 hours in the future is much lower than the probability that someone who's actively watching now, who's prefetched a break, is going to be watching in 2 minutes. Advertisers would prefer that everything be like just in time. And I assume that eventually we'll be able to build systems that don't require such convoluted mechanisms for this. Like we are building all of this to respond to effectively legacy integrations. But as I'm sure many people in this room know, and as Dan mentioned earlier, these platforms tend to stick around for a long time. And the problems that we're solving for are not easy to fix. So I suspect that this is probably a solution that will stick around for quite some time, just because of the reality of the ecosystem that we're dealing with.
I have to admit, I'm pretty naive about all this stuff. I've basically learned it at the meetups. But I'm wondering, how granular are these decisions? If my wife and I are both watching in different rooms, are we going to see different ads?
Short answer, yes. So it depends on if you're watching on, are you watching the same content? Do you have different user profiles? Are your devices different? All of these things can be transmitted as part of the user profile that is made known to the ad decisioning engines. And so your device user agent, your IP, a lot of times they'll obfuscate the IPs, but there's a lot of information that identifies you that could be used.
Okay, kind of scary.
Yeah, so there are, obviously things you can do to restrict the amount of personal information you share to these platforms. And we are very sensitive to that, and we want to make sure that our customers, our publishers, are adhering to all of the requisite laws and regulations that apply. This is especially important for children's content, and we want to make sure that we give publishers the right tools to be able to target ads appropriately based on the viewers. But the targeting can be as granular or as broad as is technically feasible. And it is the responsibility of all of us to make sure that that is appropriate.
Great question. It's kind of like the geo or regional ads, like for
Yeah.
Ford or something.
There's
like
lots
that.
of cases where an advertiser may simply bid on, like a cohort, a particular cohort. They may bid based on the geo, the location of a viewer. And so that's very normal. So you may get the same ad because you happen to be watching from Portland, Oregon. But if your viewing history is different and the publisher has created a different profile that categorizes you differently than someone else, then you could get a different ad served.
Any other questions? All right, let's put our hands together for a great conversation with Matt Scharr. And let's keep that clap going for both of our speakers tonight. It's been a great night of questions and community, so thank you very much. Everyone give yourself a round of applause.